Alright, ladies and gentlemen, we are going to be talking about similar figures and things we can talk about when we have similar figures, especially when it comes to their corresponding angles and lengths. So as a reminder, I want you to understand that corresponding means matching. It's a fancy way of saying matching. So we're going to be looking at matching angles and matching lengths. Alright? So we have a little kind of word problem here dealing with similar figures. It says Gru is 6 feet tall and casts a shadow that is 4 feet long. So let's draw that in. Gru is 6 feet tall and his shadow is 4 feet long. At the same time, Dave the minion casts a shadow that is 2 feet long. How tall is Dave the minion? So, let me draw this in real quick. We want to figure out how tall Dave is. We don't know. So because these are considered similar figures, we're going to kind of use that idea. So if you look, their shadows have a relationship from 4 feet to 2 feet or 2 feet to 4 feet. So if you think about it, shadow from Dave to Gru, we are actually, to get to Gru, we are multiplying by 2. Okay, so that means because these guys are similar, we would do the same thing to get my height. We would multiply by 2. And this is a similar figure idea. So in other words, what did we have to multiply by? So 2 times what gives me 6. So if we kind of do the mental math here, again, we need a number. We're going to multiply by 2, and it should give me 6. And if we can figure this out, Dave's height would be 3 feet. Okay? Hopefully you figured and followed along pretty easily there. There is a quicker way to figure this out using algebra, and we're going to be talking about that. But this idea of matching, in this case we match shadows, and we saw how did one shadow change into the other using multiplication. And if we can figure out the shadows, we can do the same rule for the height. Okay? So let's move on. One of the important things when we start dealing with similar figures is understanding what a ratio is and then how to solve a proportion. So let's get into the vocabulary here. A ratio is simply a fraction measured with the same units. Okay? There's a couple ways to talk about fractions. We could do our typical fraction, A fraction bar over B. Or the other way we could talk about a ratio is A colon B. And we all read these as A is to B. Okay? So when we're talking about a ratio, there's 2 ways to write them out. So just be aware of this. You're going to see this quite a bit. Okay? So moving on, a proportion is a very simple idea. It's when you have 2 fractions that don't equal each other right off the bat, or they don't look like they equal each other, but they actually are equal to each other. I'm going to do just a very simple example. For example, a proportion that's really common is if we have like 1/2 equal to 3 over 6. If you look at this, these do not look equal, but if you actually reduced 3 over 6, it would reduce to 1/2. These are two ratios that are actually equal to each other, even though they have different numbers. Okay, so this is just an example of what a proportion is. All right, so one of the skills we're going to talk about is how to solve proportions. So when we say solving a proportion, you're going to have two ratios equal to each other, and part of one of the ratios is going to be a variable. In this case, we have x here. To solve this thing, we want to use cross multiplication. Okay, it's a very simple idea. When you see two fractions that are equal to each other, this is a proportion. To solve, we are going to cross multiply. And what that means is we're going to multiply here, and we're going to multiply here. And again, it does not really matter which one you multiply first, as long as you multiply. So we'll do the x first. So x times 5, this gives me 5x, and then we put in our equal sign, always equal, and then we're going to multiply the other way. 4 times 7, that gives me 28. And now, as you can see, we have a very simple im2 equation. Our goal now is to solve for x. So I'm going to divide both sides by 5. And my answer here, x is equal to 28 over 5. Pretty simple. Let's try example B. Again, we have a proportion, two ratios equal to each other, so we are going to cross multiply. Okay, so again, I like to do the multiplication of the x's first, so we're going to go 6x times 4. That's going to give me 24x equal to 8 times 3, which is also 24. And our goal is to solve for x. So we're going to divide by 24. Turns into an im2 problem. These cancel out. X is equal to 1. Okay. Last but not least, we have this equation. And right now it does not look like a proportion. But we can turn it into a proportion because we could turn 6 into a fraction by putting 1 under it. And if we do that, this is what our proportion looks like. We're going to have 2 over 3. This x here, when we write it into a fraction, we want to take the x to the top number. So the x is going to belong to the top number, equal to 6 over 1. And now we can treat this like all the other proportions. So we're going to cross multiply to solve. So I like to do the x's first. 2x times 1, that's 2x. 3 times 6, that is 18. And now we can divide by 2 to solve. X equals 9, and we are done. Again, this is solving proportions. This is a skill you're going to need to do when we get into similar triangles. Again, when we're dealing with similar triangles or just similar figures, a big part of solving these things is being able to write proportions. Okay, so we're going to practice this on the example G. So let's fill in this little sentence frame here. It says, when writing a proportion between two similar figures, it is important to compare corresponding parts. Again, corresponding parts. Corresponding just means matching. Okay, and the parts we're talking about, there's two types of parts. There's corresponding angles and corresponding sides. For this example here with Drake, we're really going to focus in on the sides, okay? So if you read, it says you have an 8x10 photo of Drake that you want to reduce to width of 5.5. inches for your super rad singer scrapbook. What is the length of the reduced photo? So again, we're taking this photo and we are making it smaller. And we're making it smaller in such a way that we need to figure out what is the length of the photo. So we're trying to solve for x. So in essence, what we're going to do is we are simply going to compare corresponding parts. In this case, we're comparing sides, the lengths and the widths. So if you look, 10 inches, which is the width, would match with who over here in the smaller photo. And that's really easy to see. 10 would match with 5.5. So we're going to create a proportion. So we're going to go 10 over 5.5. Okay, so to create a proportion, I need to also create another ratio. So to create this second ratio, we got to match another set of sides. So when we did our first ratio, I did 10 from the bigger drawing, so he went on top. The part that matches from the smaller drawing went on the bottom. So we got to keep this order. Big drawing on top, small drawing on bottom. So when we do this next ratio, we're going to go big drawing first. So we're going to take 8, because that's the only other side that we know. And we are going to match it to the other smaller, in this case, length. And that's x. So it's going to go here. Now once we have a proportion, just like we did in the previous slide, we can now cross multiply to solve. So let's do that. I like to cross multiply the x first, so it's going to be 10x equals to 44. And then again, we're just going to solve for x. So I'm going to divide both sides by 10. X is going to equal 44 over 10, or we can reduce it by 2, and that's going to give us 22 over 5. Okay, so that's pretty much setting up a proportion. The key is, again, find the corresponding parts and turn them into two fractions. In this case, we use the sides to turn them into two fractions. To solve any missing part of the fraction, cross multiply and solve. Okay, let's go ahead and do these two examples at the bottom. It says, given the ratio of 1 over 2, can we figure out the value of x if we have 3 to x? Alright, so it's very important that we understand 1 colon 2 can be written very simply as 1 over 2, and if we want to solve for x, we got to put it equal to a new ratio or new fraction, and lo and behold, we have our other fraction here, so we can put that as 3 over x, and there we go. We have our proportion. We can now cross multiply to solve. So I like to do the x first, so it's going to be 1 times x, or just x, equal to 6, and again, there's nothing to solve for. Okay? Alright, same thing applies for extended ratios. If you notice, we have, instead of just 2 numbers, we have 3 numbers. But, for example, we want to solve for x. So we are going to ignore this stuff. For now, let's ignore that and pretend that we just have this setup here. Okay, so we're going to go ahead and write this as a fraction. So 1 over 2 again, 1 over 2 turns into 1 over 2, okay, is equal to x over 4. Now we got our proportion. Cross multiply to solve. I like to multiply with the x first, so it's going to be 2x equal to 4. Divide by 2. And x is equal to 2. Okay, so we solve for x. Now let's go back to our proportion here. And again, we're going to set up a new proportion, but this time I'm ignoring the x guy, and I'm going to set up this proportion. So it's going to be 2 over 5 equal to 4 over y. And now we cross multiply. Again, I'm going to do the multiplication of y first. So it's 2y equal to 20. Divide by 2. And y is going to equal to 10. Alright, and that's how you do an extended ratio. Notice that my proportions, again, we have more than one variable here. We have x and y. But when I set up my proportions, one of them had a variable, the other ratio, did not have a variable at all. It had two numbers. Same thing over here. One of my ratios had the variable y, the other is not allowed to have a second variable. So it's very important that when you start setting up your proportions, that at least one fraction has just numbers in it, just like 1/2 and over here 2/5. And the other fraction is able to have the variable. Alright, so again, these are skills we're going to need for solving and proving similar figures in the future.